name is Spiritu, and I will be the one to explicate about the Gauss-Seidel method. It's also known the Lehman method, or method for successive displacement. It's an iterative method, or technique used for solving systems of linear equations. And you can guarantee the convergence if the matrix is diagonally dominant. So to check if it is diagonally dominant, first you have to equate it from the biggest number in this first equation and the absolute value of 2 plus the absolute value of 1, which is 3, correct? And 7 must be greater than the absolute value of 3 plus the absolute value of negative 1, which is equals to 4, and it's also correct. For the third equation, you have 10, which must be greater than the absolute value of 1 and the absolute value of 5, which is 6, which is also correct. So, we now know that our equations is diagonally dominant. So, to know the true value of these equations, we can use our calculator by pressing the mode 5 and then 2 and put all these numbers in it. So, our true values is 55 over 41 for x1, 21 over 41 for x2, and 66 over 41 for x3. You'll have to use the iterations given, which is for x1 0, x2 is 0, x3 is 0, and equate x1 to be equal to 8, and then transpose the other numbers, which will be 2 x2 and negative x3 all over 4. Then substitute the given equation, the given numbers. So 8 minus 2 times 0 minus 0 all over 4 should be equal to 2. And for x2, we'll have 9 all minus negative 3x1 plus x3 all over 7, which will then be equal to 3 over 7. And for x3, 20 minus x1 minus 5x2 all over 10, which will be equal to 111 over 70. After knowing the values of x1 to x3, we'll now write the present value of x1 to x3, which will be equal to 3 over 7 and 111 over 70, which our previous value is equals to 0, 0, and 0. Next, we'll have to find the relative approximation error for equation number 1. First, you should know the true value minus the actual value all over the actual value times 100, which shall be equal to 0 minus 2 all over 2 times 100, which will be equal to 100%. And for the next equation, our relative approximation value will be equal to the absolute value of 0 minus 3 over 7 all over 3 over 7 times 100, which is also 100%. And lastly, for our equation number 3, we have the absolute value of 0 minus 111 over 70 all over 111 over 70 times 100, which is also 100%. After getting these relative approximation values of the equations 1 to 3, we can now proceed to the next iteration. For our iteration number 2, we'll just do what we have done on the iteration number 1, which will be x1 is equals to 8 minus 4 minus 2x2 minus x3 all over 4. But in this iteration number 2, we will substitute the values of x1 to x3 using our present values we've obtained in iteration number 1. So, x1 will be 8 minus 2 times our present value of x2, which is 3 over 7, minus our present value of x3, which is 111 over 70 all over 4, which gives us 389 all over 280. For x2, we'll just do the same, which is 9 minus 3x1 plus x3 all over 7. And now, we'll use the value of x1, which is this. So 9 minus 3, 389 all over 280 plus our present value of x3, which is also 111 over 70 all over 7, which gives us the value of 1797 all over 1960. And lastly, for our last equation, which is x3 will be equal to 20 minus x1 minus 5x2 all over 10. This one will now substitute the values of x1 and x2 in iteration number 2. So it will be 20 minus 389 all over 280 minus 5 times our x2 in iteration number 2, which is 1797 all over 1960 all over 10, which will be 1.4027. After getting the values of x1 to x3 from the iteration number 2, we also put it in our present value, which is 389 over 280 for x1, 1797 over 1960 for x2, and for x3, 1.4027. And our previous value, our x1 to x3 is equals to 2, 3 over 7, and 111 over 70. For this iteration number 2, we will also get its relative approximation errors. For the values of x1 to x3, we have obtained. So, for iteration, for relative approximation, for equation number 1, we have the true value of 2 minus the actual value, which is 389 over 280 all over 389 over 280 times 100, which is 48.96%. And for equation number 2, our relative approximation value will be equal to 3 over 7 minus our actual value for x2, which is 1797 over 1960 all over 1797 over 1960 times 100, which will be equal to 53.26%. And lastly, for our equation number 3, we have the absolute value of 111 over 70 minus 1.4027 over 1.4027, which will be equal to 13.05%. For the next iterations, you can use the following algorithms in solving it. So, I hope you understand what is Gauss-Seidel method all about. So, thank you for watching.